Setting up, initializing. All right, we're letting him in.
Okay.
Rock and roll.
Oh, but I already put 250 of the security deposit towards it, so.
Equal. Hello.
Hey, everybody. Hi, this is Andres Martinez. You guys remember us? I'm a NASA engineer. In my office, remember, my office is only 10 miles from your schools. NASA is in your neighborhood. Welcome to Destination Space. So we started Destination Space in February. We had 15 presentations, and then in March we had 17, I think. And then last month, in April, we had, I think, 9. This month we're only going to have 2, but they're incredible presentations. So I'm glad you could join us. This month we're going to talk about the moon and some of the tools that we developed. And we have with us Mr. Brian Day. Mr. Day is a deputy staff scientist at the NASA Solar System Exploration Research Virtual Institute. We call it SERVI. And SERVI is at NASA Ames Research Center, not too far from your schools, not too far from where you're connected right now from your homes. He's going to be talking to us today. He's going to give you an introduction to Moon Trek. And he's going to help us explore the moon. It's going to be a virtual exploration of the moon. He's going to take us to the moon, and you're going to see what it's like to be on the moon. Is everybody ready? All right. Remember, we only have one rule, and that is to show our, lots of courtesy to Mr. Day. All of us are going to mute our mics so that he can share with us his incredible work at NASA. All right, Mr. Day, I'm going to stop sharing, and I'm also going to go on mute so that you can share with us your incredible app and take us
very good
today.
Thank you very much. I appreciate it. So I'm going to share my screen here. And I'm going to talk to you today about the moon and how you can explore the moon along with us. So this is a very exciting time. We are going to, well, here's the moon, and we're going to be sending robots and people to the moon very, very soon. We're going to explore the moon in great detail. And pretty soon, people are going to start living and working on the moon. Now, you can join us in that exploration through some tools that we've developed and that we are using to plan our missions. And you can use these tools yourself by going to trek.nasa.gov, trek.nasa.gov. And when you go there, you'll have the option to explore a number of different worlds. But today we're going to focus on the moon. And so we'll zoom to the moon here. And with Moon Trek, we can do a lot of things. We can look at the moon, we can spin it around. And first thing we see is that when you look at the moon, and you've probably seen this with your own eyes, there are dark areas and there are light areas, different kinds of rock. The dark areas are low and smooth. And this is where great lava flows have spread out and covered the surface of the moon in these areas and hardened into great, large, flat lava flows. Whereas the light areas are much rougher and higher. These are the highland areas of the moon. And you can see these in very clear detail using Moon Trek. Now, what we can also do is we can zoom into any area we want. We can pan and we can zoom. And so here we'll zoom into one of these impact craters where an asteroid crashed into the moon and it left this big hole, this big divot in the moon. And as you look at this, you might say, well, gee, how big is that? That's actually really easy to tell using Moontrack. So we can, as simple as drawing a line, we'll just draw a line from one side of the crater to the other here. And there it goes. It tells us that this is 86 kilometers across. That's about almost 50 miles across. That's a big hole in the ground. So then one of the next questions you might want to ask is, well, how deep is it? And again, that's really simple to do. So we'll get into our tool here, elevation measurement. And again, as simple as drawing a line. This time, let's extend the line a little bit beyond the rims here so we can actually see the rim in our measurement. And what it is going to show us is, as we go across this line, we can see the height. We can measure the heights of mountains, the depths of craters. You can do all kinds of neat measurements. So this helps you explore the moon very neatly. Now, another thing we can do is we can, I'm going to zoom out just a little bit here. We can draw a bounding box around any area we like. And if we do, it gives us the option to generate a file that we can then send to a 3D printer. So you can make 3D prints. I'll show you an example of that a little bit later. Another really fun thing we can do is you can draw a path anywhere you want on the surface, like this. And it comes back to you with a QR code. You scan that QR code into your smartphone, either Apple or Android, and then you put your smartphone in a pair of cheap $5 Google Cardboard compatible 3D goggles, and whatever path you drew, you will now fly in virtual reality. So that's kind of cool. But one of my favorite things to do is switch Moontrack into its 3D globe mode. And so here, what we can do is we can interactively go flying across the surface of the moon. You can take the controls with your mouse and your keyboard, and you can go flying around the moon, exploring it, finding wonderful, wonderful things to look at. And the moon is a fascinating place. There's a lot going on. So you can see how I'm just manually flying around exploring the moon. This is a lot of fun. Now, something else we can do is we can take a look. We've got some guided tours. And so we can take a look at some of the places where we have been. So you may have heard of the Apollo missions back in the late 1960s and early 1970s, when we sent the first people to the moon. We can take a look at where some of these places were. So for instance, the first landing on the moon back in 1969 went to this area here called the Sea of Tranquility. And as we look, they were going to land in a nice smooth area, but as they came down, their autopilot brought them down toward this big crater here, full of boulders about the size of cars and even houses. And as astronaut Neil Armstrong looked out the window, he realized, oh my gosh, we can't land there. So he took manual control and he started flying off to the west, and he kept flying. And look at this right here. We can actually see this is the descent stage of the lunar module. This is what the astronauts rode down to the surface of the moon on. And it's still sitting there today. We can still see it there. We can see some of the scientific experiments that they left on the surface. A laser retroreflector that we can bounce laser beams off the moon with, and a seismometer. And if you look very carefully, you can see some dark squiggly lines here. These are the actual footprints of the astronauts as they walked on the surface of the moon. That's really exciting. But something else is about to happen that is, I think, even more exciting. And that is the fact that we are going to end up sending people to the moon again. And we're going to do that by sending people and robots to a very interesting place, someplace we've never been yet. This is the South Pole of the moon. And we'll take a look. One of the neat things Moontrek lets us do is view the surface of the moon, seen through the eyes of many different instruments on many different spacecraft. So here we can change our camera view and get a nice close-up view. And as we look at the South Pole, we see that this is an area of deep shadows because the sunlight is just coming in, skimming the ground horizontally. And there are craters here near the South Pole of the moon whose floors have not seen sunlight in over 1 billion years. They are very, very, very dark places. And these shadows make it hard for us to really visualize, to see a lot of this terrain that we want to explore. But fortunately, we can use some other instruments. We can see through the eyes of something like a laser altimeter that bounces a laser beam off the surface of the moon from an orbiting spacecraft. And it measures how long it takes that beam to bounce back. And by measuring that time, it's able to measure all the ups and downs very, very precisely, and to pierce those shadows and give us this detailed view looking inside those craters. We can also use that to create these color-coded slope maps that'll help us plan our path across the lunar surface. Here, red color is dangerously steep, whereas blue and green are probably good ideas, good places for us to rove safely. Now, I mentioned how much of a problem those shadows are, but some of those shadows actually come in very handy. So here I'm going to overlay, these are the areas where the shadows are permanent, where the sun just never shines. And because these areas are so very, very, very dark, they are very cold. And we think that these could be areas, as a matter of fact, let's go ahead and overlay. Here we can see, we can take the temperature of these areas. And again, red is hot and blue is cold. And we can see that these areas are, as a matter of fact, the coldest places we have ever measured in the solar system, even colder than the surface of Pluto, because they have just been dark for so very, 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 very long. And because they are so dark and so cold, ice is able to form there. Let's go to this view here. Here we can see, so some of these areas we have detected ice that has formed. And that's really important because ice is frozen water. And if you're going to live and work on the moon, water is something you're really going to need to live. You're going to want to have water to drink, but also water is made of hydrogen and oxygen. Now, oxygen, we can take the water, we can break it apart into its hydrogen and oxygen. And oxygen is very important because, well, oxygen is what we breathe. And if you're living and working on the moon, breathing is something you are really, 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 really going to want to do. And we can use that hydrogen as fuel to help run our machines on the moon and to fuel our rockets. Because as cool as living and working on the moon is going to be, you're probably going to want to come back home. And here you'll have plenty of fuel to do that. So water ice is worth more than its weight in gold on the moon. That's really exciting. Now, also, when we look at the moon and look at the South Pole, we see that there are these very dark areas where the shadows are deep and permanent. But we also see that this is a mountainous area with mountain peaks that stick up very, very high. This is important because just as there are areas here that never receive sunlight, on the top of some of these mountain peaks, they stick up so high and they're so close to the South Pole that some of these mountain ridges experience nearly constant sunlight. Now, a day on the moon is about 1 Earth month long. So you'd have about, on most places of the moon, you'd have about 2 Earth weeks of light followed by 2 Earth weeks of dark. But here at the pole, you have these peaks that stick up high enough that they can get sunlight almost constantly. And that's important because right next door to shadowed areas where we have important water ice that we need to live, we also have mountain peaks that experience almost constant sunlight and give us a source of energy. If you're using solar power, this can be an almost constant source of energy. So you've got energy right next to a vital resource of water. That makes this a really exciting place. And this is why we are looking forward to sending our astronauts and our robotic explorers to the South Pole of the moon. But there are some other areas we're going to explore also. So I'm going to zoom out, and we've got some missions planned, some robotic missions planned, starting this very year. They're scheduled to start late this year. We're hoping to send a robotic probe to a place called Lacus Mortis. And so let's fly into Lacus Mortis here. And it is this smooth area coming into view in the middle of the screen right here. This is Lacus Mortis. And let's make sure I turn something off here. Okay. So Lacus Mortis is this smooth area right here. And this formed from an asteroid impact about 3.8 billion years ago. And then you can see later on another asteroid hit and made this crater here called Berg. But Lacus Mortis is about 100 miles across. And if we look really closely, we see that there are a lot of cracks across the floor. And we think these cracks happened where magma, where liquid rock, hot molten rock from deep inside the moon came up through cracks in the crust and spread the crust out, wedged it out into these long valleys here. And if we continue to zoom in and take a look, we can fly in and we can see something kind of interesting. Right along one of these cracks, you can see these two kind of round hills with holes on top of them. These are volcanoes. These are volcanoes on the moon. That's pretty remarkable. And so another thing we can do is I'm going to do a quick search here for some data. Here, we'll add that. So again, we can see through the eyes of many different instruments. And what we can do here is we'll take a look at another interesting feature. We will zoom in to an interesting looking hole in the ground right here. What we think this is a skylight. This is a place where beneath the ground, there is a lava tube, a giant cavern that was formed by lava flowing underground. And part of the roof of that cavern caved in here. And so this could give us access to this cavern underground, which might be an interesting place to explore and perhaps even to live on the moon. So Lacus Mortis is an area that is going to be explored by a robotic rover, or excuse me, a robotic lander that is going to be launched and flown by one of NASA's commercial partners called Astrobotic. They're going to carry a bunch of NASA experiments to an area right around here in Lacus Mortis. But they're not just carrying stuff from NASA. They're going to carry experiments and payloads, equipment from universities, from private companies, and also from a university and space agency in another country. They're going to be taking a series of rovers from Mexico. People at the university in Mexico City, a university called UNAM, have developed a series of robotic rovers that are going to be taken to the moon and put down on the moon's surface right about where my arrow is there. This will be the first Latin American experiments to land on the surface of the moon. And again, we're looking to see this launch at the end of this year. That's pretty exciting. Now, we've got some other places we're going to explore, and I'll give you a quick tour of them. We want to go to an area called Mare Crisium. I'll pull out here and show you Mare Crisium. It's this big kind of egg-shaped smooth area here. Imagine an asteroid coming in sideways and plowing through the ground and causing that great big divot. And as we zoom in, we can see, so, it looks like pretty much a smooth blank area. But as we get in closer, we can see an interesting feature here. Right here, let's move it into the center. This is a volcanic cone, a cinder cone. You can see kind of the south side of it was broken down. Lava flowed out through here. But this is a lunar volcano. And we're hoping to land again, one of our commercial partners is going to take some NASA experiments here. We're looking at 2023. And this partner will be Firefly Aerospace that NASA is working with, and it will take materials there. And Oh, let's keep looking. So one of the places that, another place, oh, let's zoom out a little further here. We can see, as we look, we can see some more cracks in the ground here. And these tell us an interesting story. You know, for a long time, people wondered if these craters were caused by asteroids, space rocks hitting the ground, or if they were caused by volcanoes. And there was a big argument that raged about that. And we really didn't find out until Apollo. And we sent people to the moon to actually go and study it firsthand. And we learned that the vast majority of craters on the moon are caused by impacts, but not all of them. There are some craters, like here along this crack. These are volcanic craters. So the answer to the question is, are craters on the moon caused by impacts or by volcanoes? And the answer is yes. It's caused by both. So now we'll zoom out a little further. And again, there's just so many wonderful things to explore on the moon. We could go for hours and hours and hours, but I promised Mr. Martinez I would not. But I'm going to show you another place we're looking to go. And this is also in 2023. And it's this strange area here that looks like a tadpole. This is called Reiner Gamma. You can see like the head of the tadpole here and its tail swimming off in this direction here. And we see these really strange patterns of light and dark. And people have long wondered, what in the world is happening here? Well, it turns out the moon, unlike the Earth, does not have a protective magnetic field. The Earth has this protective magnetic field around it, like a force field. But the moon doesn't have a global magnetic field. But it does have localized magnetic fields. It has local magnetic fields just in certain small areas like this. And what we seem to be seeing here is the traces of that magnetic field etched into the surface of the moon. How does that work? And why is this area magnetic? We don't know. We just don't have a clue. And so that's why this is one of the areas that we want to go explore. Now, I mentioned to you earlier that one of the things you can do is you can make 3D prints. So here's an example of a 3D print I made using Moontrek. And so you can generate these files, and if you have a 3D printer, you can make 3D prints of any area that you like. That's pretty cool. Now, normally when we do this event every year, we do this in person, and I get to come out to the school and I get to meet with the students in person. We're doing it virtual this year. But next year, when I come out, I'm going to bring with me this right here. This is a touchable moon rock. And you can reach right in here and you can actually touch a piece of the moon. And so next year, I'll bring that out for you all. So, this year you're seeing the moon and exploring the moon virtually. Next year, you will literally get to explore the moon firsthand with your own finger. Does that sound fun? All right. So I think what we want to do is leave a little time for questions here. And so if there are any questions, I'll do my best to try and answer them.
All right.
Thank
Ms.
you.
Carmichael,
Thank you
Ms. Martinez.
so much, Brian.
Yeah.
So throughout this presentation, Miss Allie has had her hand raised. So if you want to go ahead and unmute yourself, we can get your question asked.
So you had missions this year. What is your earliest mission?
So our earliest mission to the moon this year would be this coming fall. But that will launch from Florida. But let me give you a little bit of exciting news. In addition to the moon, we're going to be launching a mission to go to an asteroid. And that is scheduled to launch this November. And it's scheduled to launch from right here in California. How cool is that? It's going to launch from a place called Vandenberg, just a drive down the coast, and it's really beautiful. So that's something that maybe we should talk to the school about is, you know, at the very least, we could get a live launch stream into your school, but boy, wouldn't that make a great field trip too. So anyway, we will keep you posted on these launches coming up. I'll work with Mr. Martinez to make sure that you folks are informed of the various launches that we have coming up, okay?
Okay, so it looks like Angelica and Mateo have been waiting so patiently. So if you guys want to unmute yourselves.
And when you go to the south, huh? Oh, when you go to the South Pole, are you gonna take some animals that can live all around the world, like tardigrades?
So on our first missions, we probably will not take animals, but on later missions, I'm sure we will. And it's interesting that you mentioned tardigrades. That's a wonderful, wonderful observation. There was a mission that the Israelis tried to send to the moon recently, and they were taking tardigrades with them. But the mission didn't end up working, but it was a great plan, and we'll probably try to do that again. Excellent question. And tardigrades are cool, aren't they?
Let's see, what about Quien Tu? If you want to go ahead and unmute yourself, we can get your question asked.
So, how many years have planned on the moon?
Daniela, did you get that? I'm not sure I did.
I think she was asking how many missions we've landed on the moon.
That's a very good. So we have had so far 6 missions with people on them that have landed on the moon. Now, there have been some other robotic landers on the moon. In fact, one of our Apollo missions with people on it landed, that was the Apollo 12 mission, landed right next to one of our previous robot explorers, Surveyor 3. But so far, we have only had 6 missions that have landed people on the moon. So a total of 12 people have walked on the surface of the moon so far. We're hoping to make that number much bigger real soon.
Let's see, I'm just scrolling to see if we have more hands up. So let's see, Kiera from Miss Brophy's class has been patiently waiting. So if you want to go ahead and unmute yourself.
What if your mission fails to the moon?
Well, you know, that sometimes happens. And, you know, we've had several of our early robotic explorers that didn't work. That happens. And we do our best. We test all that we can. but sometimes things don't go the way we planned. But I'll take you back to a program we used to have at NASA Ames where we would have kids come out and they would build rockets. And they build rockets and they fly them there at NASA Ames. Kids your age were building rockets and flying them. And a lot of times their rockets would fly up into the sky and parachutes would come out and they'd float back down. But sometimes their rockets would go boom on the launch pad, or sometimes they'd take off and they'd fly sideways. And they would say, oh, my launch was a failure. And I'd say, bring me your rocket. And we bring it and we take it and put it on a table and we take it apart. We'd say, okay, what went wrong? Why did your rocket fly sideways instead of up? And we'd go and we'd take it apart and we'd figure out what was going on, and they'd learn something. And then I would tell them a very important point. Your flight is only a failure if you don't learn anything from it. If you learn something from it, then there's some success there, isn't there? So whatever we do, sometimes it will work out just like we planned, other times it won't. But the important thing is from every attempt to learn something from it. Great question. Thank you.
Okay, we have time for one last question. And so Antonio from Miss Muller's class has been waiting so patiently. So if you want to go ahead and unmute yourself.
What happens if, like, sometimes when people live on the moon, what happens if an accident happened and all the air left and there were still animals living with the persons?
So this is something that we practice for on the International Space Station. You know, we have people living in space right now. There's 7 people living in space right now, orbiting above us. I saw them fly over last night. I walked out in my front yard and it flew across the sky really fast. And the same thing you talk about there. What happens if all of a sudden they lose the air? They have to practice for that. And they have, you know, basically they look for air leaks, and if there's some sort of emergency, you get into your spacesuit. You get real quick, you get into that spacesuit, and you know, sometimes they'll have special safe places for you to go. So sometimes they'll retreat to a special space capsule. And so what we do is, as we build our outpost on the moon, we'll make sure that even though you don't always want to wear your spacesuit, you'll have one handy, and that you'll have special protective areas that you can go to in the case of an emergency. Great question.
All right. Hey, thank you, Mr. Day. Hey, so what did you guys think? Isn't that a really cool portal that we have, the Trek at nasa.gov? Who's gonna go try it right after this, or who started trying it already? It's pretty awesome, and it's only gonna get better, because as soon as we go back to the moon and we start adding more infrastructure and more people and more vehicles, then it's gonna get really interesting, right? And then we're gonna learn more about the moon. So we're gonna add all that information to the map and to the app. So it's gonna be as close as it gets, right? For all of you to follow everything we do on the moon. So by the time you graduate from elementary with straight A's or close to straight A's, and you're an incredible member of your community, you continue being an incredible member of your community, and then you move on to middle school and you continue doing really well in school, right? Because remember, the hardest part is elementary, because this is where you have to build those incredible skills that are difficult. Sometimes they're difficult to develop, right? To say, I'm gonna focus on doing my homework, and I'm gonna pay attention to the teachers and my parents and do really well throughout my community. That's when it's really difficult. Because once you have these skills, then it just comes out naturally, right? Then you just do things because you're used to doing great things. And so then middle school becomes pretty easy. High school, remember, it becomes a walk on the park. And then when you get to college, you're gonna think, wow, this is pretty simple. This is a piece of cake. And that's when you can start working with us, when you're available, right? During your summertime. And as soon as you graduate and you have already done really, really well in school the whole time, then you can come and work with us. And you can come and assist Mr. Day. And maybe, no, forget about maybe. I know some of you are gonna decide to become astronauts. Some of you are gonna remember this tool and say, I remember when I was walking through the moon or on the moon with this virtual tool. Now, look at me, now I'm here on the moon, helping NASA and helping humanity do great things on the moon, right? Who's gonna be doing that for us or with us? All right, but remember you have to do your homework, okay? Every single homework, every single assignment counts. Because the minute you start missing one assignment, then it becomes real easy for you to say, I'm just gonna miss another one. And then before you know it, it becomes a bad habit. So you wanna be able to build really good habits so that things are easier. And the more you do it, the easier it gets, okay? All right, and speaking of homework, who did their homework last night? Raise your hand if you did your homework. All right, and you're doing all your classwork today, right? Okay, very good. So let's all open up our cameras. Whoever wants to participate in our group photo with Mr. Day, so we can have something to remember. We have this video, but this will also be a nice thing to have for Mr. Day. Everyone, if you want to be in the photo. And remember, if you're gonna make a goofy face, just make sure it's a cute, goofy face, right? Because nobody wants to come out looking bad on a photo. All right? Okay, ready? We still have Cruz with a K. You gonna join us, Cruz, from Ms. Brophy? All right, 1, 2. Okay, let's see how that came out. Oh, Cruz came back. Hold on one second, one more time. Big smile, everybody. 1, 2. Okay, hold on one second. 1 second. That's a nice photo. All right. Well, can everyone please help me give Mr. Day a huge, tremendous round of applause? Mr. Day is one of our best scientists at NASA Ames Research Center and at NASA in general. So we're very lucky to have him today. And guess what? We're gonna have him again next week, because next week we're gonna have an eclipse, a lunar eclipse. And he's gonna come and tell us all about that so that we can be ready for it, okay? So next week, a lunar eclipse, it's happening on the 26th. But we're gonna have our talk. He's gonna come back. Mr. Day's coming back next Tuesday at the same time, same link. Don't forget, come join us. He's gonna come back in and tell us all about this eclipse that's gonna happen the day after, okay? So that all of us are informed and we know what to look for, okay? And remember, we're doing all these talks, Destination Space. It's all about you, it's for you, because we know you're special. And we know many of you are gonna come and work with us, all right? So thank you again, Mr. Day. It was great. And we're gonna sign off. Everybody stay safe, do well, and we'll see you next week, next Tuesday. Bye-bye.
Bye-bye.
Bye. Bye. Thank you.